Synthetic polymers have changed the world around us, and it would be hard to imagine a world without them. However, they do have their problems. It is, for instance, hard from a synthetic point of view to precisely control their molecular structure. This makes it harder to finely tune some of their properties, such as the ability to transport ions. To overcome this problem, University of Groningen assistant professor Giuseppe Portale decided to take inspiration from nature. The result was published in Science Advances on July 17, a new class of polymers based on protein-like materials that work as proton conductors and might be useful in future bioelectronic devices. I have been working on proton-conducting materials on and off since my PhD, says Portale. I find it fascinating to know what makes a material transport a proton, so I worked a lot on optimizing structures at the nanoscale level to get greater conductivity. But it was only a few years ago that he considered the possibility of making them from biological, protein-like structures. He came to this idea together with Professor Andreas Hermann, a former colleague at the University of Groningen, now working at the DWI Leibniz Institute for Interactive Materials in Germany. We could immediately see that proton-conducting biopolymers could be very useful for applications like bioelectronics or sensors, Portale says. More active groups, more conductivity, but first, they had to see if the idea would work. Portale: our first goal was to prove that we could precisely tune the proton conductivity of the protein-based polymers by tuning the number of ionizable groups per polymer chain. To do this, the researchers prepared a number of unstructured biopolymers that had different numbers of ionizable groups, in this case, carboxylic acid groups. Their proton conductivity scaled linearly with the number of charged carboxylic acid groups per chain. It was not groundbreaking, everybody knows this concept. But we were thrilled that we were able to make something that worked as expected, Portale says. For the next step, Portale relied on his expertise in the field of synthetic polymers. I have learned over the years that the nanostructure of a polymer can greatly influence the conductivity. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you new tech videos. Thank you.